Hello students, today we'll discuss IB Physics SL Paper 2, May 2019. My name is Nariman Merlim. I'm located in Baku, and here you can see my mobile and email. To prepare for exam, you can use a huge textbook of Oxford 2014 or short textbook by Tim Kirk of Oxford 2014. From examiner, you should have physics data booklet which includes formulas, and this booklet will be available for you during exam. This is the cover page. Most of questions are the same as in HL paper. Question 1. A girl rides a bicycle that is powered by an electric motor. A battery transfers energy to the electric motor. The EMF of the battery is 16 volt and it can deliver a charge of 43 kilokelvin when discharging completely from a full charge. A. The maximum speed of the girl on a horizontal road is 7 meters per second when energy from the battery are low. The maximum distance that the girl can travel under this condition is 20 kilometers. Shows that the time taken for the battery to discharge is about 3 times 10 to the third second. So maximum distance, maximum speed. So speed equals distance over time, time equals distance over speed. Distance kilometers we change into meters by multiplied by 1000, substitute values, and we get what is required. Deduce that the average power output of the battery is about 240 watts. So section 5.1 of booklet give us voltage equals work over charge, or work equals voltage by charge. Voltage is 16 volt, and charge we change into coulomb. On the other hand, section 8.1 power equals energy over time. So energy equals work over time, work we change by voltage by charge, and substitute values that we have, and we get 240 watt. By the way, so I used not the last answer, but intermediate answer with 3 significant figures, so I got what they required. 3I. Friction and air resistance act on the bicycle, and the girl, when they move, assumes that the energy is transferred from the battery to the electric motor. All energy is transferred from the battery to the electric motor. Determine the total average resistive force that acts on the bicycle and the girl. So resistive force equals, we assume that girl is moving at constant speed. So resistive force equals force of engine. On the other hand, section 2.3 power equals force times speed. Force equals power by speed. Power by speed give us the force, 34 Newton. B. The bicycle and the girl have a total mass of 66 kilograms. The girl moves up a slope that is at an angle of 3 degrees to the horizontal. I. Calculate the component of weight for the bicycle and girl along the slope. So note in the booklet, remember, component of the weight along the slope equals mg sine angle of slope. Here it is 3 degrees, so we get 34 Newton. 2 significant figures. I. The battery continues to give an output power of 240 watt. Assume that the resistive force are the same as in A3I. Calculate the maximum speed of the bicycle and the girl up the slope. Sum of 2 backward forces, it is resistive force and component of weight, it is 68 Newton. So it is balanced by force from engine, and again section 2.3 power equals force times speed, speed equals power by force. 240 by total force give us 3.5 meters per second. On another journey up the slope, the girl carries an additional mass. Explain whether carrying this mass will change the maximum distance that bicycle can travel along the slope. So first, our statement, maximum distance will decrease. Reason, due to conservation of energy, electrical energy will turn into potential energy, and potential energy is mgh. So greater mass means less height, and less height means less distance traveled along the slope. D. As the bicycle has a meter that displays the current and the terminal potential difference for the battery when the motor is running. The diagram shows the meter readings at one instant. The EMF of the cell is 60 volts. Determine the internal resistance of the battery. So 16 volt is EMF. Part of this EMF falls on external resistor. It is what the voltmeter measures. It is terminal potential difference 12 volt. It means that 4 volts, the difference, falls on internal resistor. This is called lost volts. So lost volts equals EMF minus terminal potential difference. Here it is 4 volt. So this voltage falls on resistance, and to find resistance we divide the voltage on current. Current, external, internal resistance is the same because they are connected in series, so it is 6.5. We put these values here and we get the value of internal resistance. E. The battery is made from an arrangement of 10 identical cells as shown. Calculate the EMF of one cell. Let's call EMF of one cell X. Then EMF of parallel connection will be also X. We have 5 of them connected in series, so we have 5x volt, and this 5x equals total EMF of the battery, 16 volts, so X equals 3.2. Internal resistance on one cell. So if we call internal resistance of one cell X, then internal resistance of this section will be X over 2, and we have 5 sections connected in series, so X over 2 multiplied by 5, so we have 2.5x, which is equal to internal resistance of the battery. So we are finding X, we get the value 0.25 ohm. Question 2. Silicon 30 can be formed from phosphorus 30 by a process of beta plus decay. Write down the nuclear equation that represents this reaction. So phosphorus is turning into silicon. Don't forget neutrino, and put 0, so the top and bottom values should be balanced. So here you see they are balanced. Sketch the Feynman diagram that represents this reaction. The diagram has been started for you. So here we have beta plus decay. We can go deeper into detail, so we can change this change of nucleus into change of one of the protons. Actually, one of the protons change into neutron, sending out beta particles, a neutrino. Or if we go deeper, actually one of the quarks, upper quark of proton, change into down quark, and beta plus particle and neutrino. So we have here decay, and decay is accompanied by weak interaction, and mediator is W boson, and here it will be plus W boson. Why? Because upper is positive, down is negative, so we should have here positive charge going away. So I copied this diagram in here. So we have this upper quark doesn't change, but the last one, for example, changes, decays here, decays into deep, turns into deep, and send out W plus boson. Then W plus boson turns into beta plus particle and neutrino. Because beta plus particle is antiparticle, we show arrow against time. Neutrino is particle, so we show it in the same direction. Energy is transferred to a hadron in an attempt to separate its quark. Describes the implication of quark confinement for this situation. So quarks cannot be isolated, and in this situation, when we give energy, we see that one of the quarks, at the expense of this energy, turns into another quark. Another particles are created. B. The standard model was accepted by many scientists before the observation of the Higgs boson was made. Outline why it is important to continue research into a topic once a scientific model has been accepted by the scientific community. All models still need testing. Now we go to question 3. Question 3. A beam of microwaves is incident normally on a pair of identical narrow slits S1 and S2. When microwave receiver is initially placed at W, which is equidistant from the slits, a maximum in intensity is observed. The receiver is then moved towards Z along the line parallel to the slits. Intensity maxima are observed at X and Y, with one minimum between them. W and X and Y are consecutive maxima. So we have two waves from S1 and S2. They superimpose here, and the result of superposition depends on path difference. A. Explain why intensity maxima are observed at X and Y. Two waves superpose, and constructive interference takes place when they come in phase. So for constructive interference, path difference should be n lambda. As at W, path difference equals 0, hence at X, path difference equals lambda, so n equals 1, and at Y, path difference equals 2 lambda. Next question. Question 4. A solid cylinder of mass h and density ρ rests on a flat surface. A. Shows that the pressure exerted by the cylinder on the surface is given by ρgh. Actually, we are using form for pressure from liquid. Section 3.2 give us pressure equals force over area. Here force is weight, so force equals mg. On the other hand, mass equals density by volume. On the other hand, volume equals area by height, because this is cylinder. Substituting these expressions and cancelling A, we get ρgh. B. A tube of constant circular cross-section sealed at one end contains an ideal gas trapped by a cylinder of mercury of length 35 mm. The whole arrangement is in the Earth's atmosphere. The density of mercury is so much. When the mercury is above the gas column, the length of the gas is 0.190 meters. Shows that this expression is right. So first of all, total pressure is atmospheric pressure and pressure of this mercury. On the other hand, section 3.2 give us ideal gas equation, PV equals nRT. So V equals volume of cylinder, area by height. So height is 0.190. We substitute it into the ideal gas equation, and then we put total pressure for expression, and we get what they require. Double I. The tube is slowly rotated until the gas column is above mercury. The length of the gas column is now 0.208. The temperature of the trapped gas does not change during the process. Determine the atmospheric pressure. Give a suitable unit for your answer. We will work in SI units, so answer will be in Pascal. Using previous results, we have this expression. But for new situation, total pressure will be atmospheric minus pressure of mercury. The height of the gas will be 0.208, but right side is the same. So right sides are equal, so left sides are equal. So if we equate left sides, simplify, we will get the following expression for atmospheric pressure. Now we need pressure of mercury, but in the previous question we did use formula rho GH, so we will use this formula. So we get pressure of mercury, and then we can calculate atmospheric pressure. So we get something like 103, 3 significant figures, times 10 to the 5th Pascal. So this is reasonable atmospheric pressure. 3I. Outline why the gas particles in the tube hit the mercury surface less often after the tube has been rotated. The same number of particles to collide with the largest surface area at the same speed. Same speed. Why same speed? Because the same temperature. Question 5. A small metal pendulum bob of mass 75 grams is suspended at rest from a fixed point with a length of thread of negligible mass. Air resistance is negligible. The bob is then displaced to the left. At time t equals 0, bob is moving horizontally to the right at 0.8 meters per second. It collides with a small stationary object also of mass 75 grams. Both objects then move together with motion that is simple harmonic. So simple harmonic. A. Calculate the speed of combined mass immediately after the collision. So section 2.4 give us formula for momentum. Momentum equals mass times velocity. Conservation of momentum tell us that total momentum before equals total momentum after. Total momentum before is m times v. After we have combined mass 2m and unknown speed x. So x will be half, which is 0.40 meters per second. Shows that collision is inelastic. In inelastic collision, kinetic energy is not conserved. Let's check. So kinetic energy before is half mv squared. Kinetic energy after is kinetic energy before divided by 2. In Mach schemes, they give values. Initial energy 24 millijoule and final energy 12 millijoule. Energy is lost. Inelastic collision occurs when energy is lost. C. Describe the changes to gravitational potential energy of the oscillating system from time t0 as it oscillates through one cycle of its motion. So in the Mach scheme, they give potential energy at extremes, minimum in the center. So you can use this. Or describes so step by step. So first 0, then at the highest position maximum, then again 0, then maximum, and so on. So you can write this way also. Question 6. The moon has no atmosphere and orbits the Earth. The diagram shows the moon with rays of light from the sun that are incident at 90 degrees to the axis of rotating of the moon. A black body is on the moon's surface at point A. Shows that the maximum temperature that this body can reach is 400 Kelvin. Assumes that the Earth and the moon are the same distance from the sun. Section 8.2 give us power of emission by object at temperature T. We rewrite this formula for temperature by making false root of both sides and rewriting a bit. Sigma is constant, Stefan-Boltzmann constant. So how much power is emitted, so much power should be coming from the sun, because we have equilibrium. It means that power by area, which is intensity, should be equal to solar constant. Solar constant is given in the booklet. We substitute this value, so E is 1 for Blackbody, sigma is Stefan-Boltzmann constant, and power over area is solar constant. Substituting these two values, we get 393, which is about 400 Kelvin. Another black body is on the Moon's surface at point B, outlined without calculation. Why the maximum temperature of the black body at point P is less than that at point A? Intensity is lower at B because we have greater surface falling at the same power falling on the greater surface. So using the same formula, we see that if intensity is less, temperature should be the less. B. The albedo of the Earth's atmosphere is 0.28. Outline why the maximum temperature of a black body on the Earth when the sun is overhead is less than that at point A on the Moon. So albedo gives us fraction of scattered power. So 28% is scattered. It means that only 72% is incident. So less intensity, less temperature. The Moon orbits the Earth in a circular path. Outline I. The force acts. Why a force acts on the Moon? Gravitational attraction between two masses, Moon and Earth. The force does not work on the Moon. Force acts at 90 degrees to velocity, so no work is done. According to section 2.3, work equals force times displacement, cosine angle between them, so angle is 90 degrees, work is 0. This finished the paper. Thank you for your attention. See you next time.